So I wanted to talk about being able to use Python to pull data from some hardware. And the hardware is this hardware. It's a biosensor, set of biosensors from a company called Wildevine. And the hardware is called an IOM. And what that is, it basically is this, you can kind of see it here. It's a white device with some finger sensors, and they check your heart rate as well as your galvanic skin response. Okay, so there's no API on this, and there is very little information for developers. I reached out to their team to see how I could pull this data off the device. They seemed they were okay with it, it's just they wouldn't support me on it, and they have no open API, and they just said, well, we hire developers from time to time for our games. They have these biofeedback games, and I don't want to make a biofeedback game. I just want to collect the data from the machine, because the data that they pull from it, they average it. They don't give as much detail as what you can get straight from the machine. So I wanted to go ahead and do this, and I know there was a solution for this in Windows, but there was nothing for Mac. And so I thought, well, let's try a few ideas. So I went to Python initially, and this is the final script, but initially I went to this idea, this concept of using PyUSB, which makes use of the libUSB library that you can install on OS X. You install it with a brew install, and it actually was a great idea except for one problem. I'm going to go ahead and run this. Look at that. You get this access denied problem. And the reason why, here I'll go up to it. The reason why you get this, no matter if you run it with sudo, the script is sudoed or not, you're going to get an access denied. It turns out that libUSB doesn't have the permissions in OS X to bind to to the USB to listen to it. You can't do it, so you have to actually remove it from the kernel, and then you have to attach it again yourself. So you have to release the interface, and then you have to attach to it. I really didn't want to mess with that, and you can't do that with lib USB. So everybody says use libhid, HID, libhid. Use that instead. Now I'm totally new to USB programming, and I went ahead and looked at libhid. There is a brew install for it for OS X, and it didn't work. I installed it, but Python still does not recognize libhid on the system. So at that point, I somewhat gave up. There were some other ideas of code that I found online. This is a workable piece of code I found online, written in Python, and it works in Windows, but because it's using libhid. Unfortunately, it does not work in OS X. So I came along and thought, after a few days, I thought about this, and I said, well, there has to be a solution. I mean, this device is talking on some port. So what port is it talking on? And I'll listen in. So if we look at the options of the device, we'll see that this is the device, the IOM control panel, and it says it's talking on port 8888. So I tried, I decided I would sniff that port and see what I could find. So let's go ahead, I'm going to go ahead and do it right now live. I'm going to use Wireshark, and the device is plugged in, the IOM. I'm just not going to put my fingers in it, but it should pull up some data. It will be null data, but that's fine. So we're going to go ahead and start. Oh, let me go back and show you what interface I'm on. I'm going to use the loopback interface. I'm going to go ahead and do a start. And I'm going to show you one more thing. When I click start, I'm going to open up this public utility made by Wild Divine that will pull, that's designed to pull data from the IOM. So once I hit this page, let's see what happens. So I'll go ahead and hit start. Alright, let's go back here. Let's hit the grapher. Their software is loaded. Great. Let's go ahead and stop the capture. Alright, so a bunch of stuff came in. I'm going to go through the packets here. So now I can see I'm hitting some Wild Divine stuff. And I noticed this, command status. So that's getting passed in there. And I see this device connecting. And then I got this. And this is during the load of that page. Command value start, variables, and a whole bunch of variables. Turns out that's the command that is sent to the socket, and that turns on the hardware. Now let me back up a bit. This is the final script, and if I run it, oops, wrong script. If I run this script, we pull out all this data from the hardware. The heart rate, all kinds of stuff is coming through. So what I ended up doing, this is the final script, but the original script was like this. I didn't have that. So let's turn this off. So I was just listening to port 888, and here's what I would get. Nothing. So originally nothing was coming through. So I went ahead and opened up this window, which is the it's kind of a utility for the hardware, and you can manually start it. And when I hit start or stop, I saw these things appearing in the output. So it does know there's a device there. So it's working, it just wasn't sending me feedback. So that got me into the idea that something from the software is sending a signal to the hardware. And I lucked out because they have some of their software online, which means that this little guy, once I hit this page, check this out, all of a sudden it starts streaming data from the device. So my script was fine. It connected to the port and I could print out what was being picked up. So that told me there was some kind of signal being sent. So I looked on the page and there's really nothing on the page but an embedded Swift. And so, you know, without trying to get into decompiling anything, I just said, well, let's open Wireshark and let's listen to the loopback. And that's when I found this. And I saw that there was this command start. Before that I saw there was other commands being sent. And since this is the only site I was opening, I knew that it was being sent from Wild Divine to the hardware. And I saw that it said command value start, and then it looks like XML, and then we got variables, and then all these variable codes, SR, HR, and HR sounds like heart rate. And you've got BR, which is breath rate. So I began to say, oh, this is all the data. So I created the same XML that's here, put it in the script, and commented it. You know, I'll uncomment it here. And then I'm going to go back and turn off that page so we're not sending the start command. And now I hit run, and there's the data. So that worked. Now what about this guy? Well, I noticed this command was coming through early on. When I didn't have this, I also wasn't getting any data. See, nothing. So I noticed in the output previously that I was getting these being sent. So I wrapped this with whatever command that is, and there you go. There's all the data. At this point, all we have to do is parse the data. So you don't have to do a lot of trickery. You don't have to use libhid. You don't have to use libusb. All we're doing is simulating the same call that the software is making to the same port that the hardware is listening on. And we can gather all the data. At this point, we could parse the data and drop it into a file or whatever. I'll go ahead and put my fingers into this device, and we'll make sure that it's pulling up real data here. Okay, my fingers are connected, and let's just verify the connection. So you can see this is my heart rate. So now I'm going to stop that, go back here, let's hit start, stop it, and there you go. This is my galvanic skin response, which is 3.46, and this is what I wanted. Notice it goes to 2 decimal places. The actual software provided by Wild Divine only goes to 1. And with galvanic skin response, a lot of times numbers are really low, especially if you're very sedentary like myself. You're not going to get numbers like 8 or 9. My son, he'll have numbers like 10, 12, and it's very easy to see change. But when you have when you're down between 1 and 3, you're going to be moving into in like the 10th decimal place. So it's going to be like 3.46 to 3.47, and I want to see that change. And that change would be hidden from me because they're always rounding up in the software. So now I could pull this data out and actually see the raw data myself and get it to that 2 decimal places. You can also see the heartbeat, 72, goes out pretty far, but we can just leave it there. 72, I think that's beats per minute. 86, you can see how it's been fluctuating. And there you have it, all the data. I'll do another video on parsing the data, but I thought this was pretty cool that you could have some hardware that has no OpenAPI and still find a workaround with no libraries to get the data out using Python.